right. Welcome back, Baseliners. We are live with another Baseline show. Oh,
And we
featuring
have
Sonal,
Sonal.
a special guest today. Unexpectedly. Welcome.
Which part of Italy are you touring right now?
I am in Tuscany in the hills right now.
That's what I said. Didn't I say just that? We're in Tuscany. Greve?
In San Gimignano.
San Gimignano. Mi
I show you
piace
my
molto.
background, you'll be jealous.
It's I know San Gimignano very well.
But
It's
still
gorgeous.
show me.
Yeah.
I'm not Lambda.
Yeah.
I don't know
See,
what
the
it looks like.
background is like the
Background is
Northeast.
blurred.
Whoa. Whoa.
Okay. Is that a vineyard behind you?
A ton of them.
Wow.
It
That was a
is.
quick
It's
tease.
not. It's not bad. It's not bad. The food, the wine. That's all you need.
Awesome.
And after the food, un caffè normale.
Affogato.
Avocado.
No.
Oh, I'm sorry, Lambda.
It's like
Forgive me.
no. It's like that's well, you can if you want to,
No,
but it's
Keith,
like
no.
a real coffee. It's like grappa, un grappa e un caffè normale. Right? Espresso is unknown in Italy. If don't even ask for that. They don't know what that is.
Okay. I got it. Tell me more.
Welcome to the Baseline Italy show, by the way, everybody.
Baseline.
Baseline is in Italy this week, and
That's
we're featuring Sonal Patel from Italy, live from Italy.
Yeah.
Yes.
And Andres is
Video
gonna.
drinking
E
wine.
oggi siamo insieme a Italia di San Gimignano.
Andres is gonna teach you how to order all you need to order in Italian.
The
Sorry,
cool thing
Lambda.
about an AI is that they know everything. So
Infatti. Sono conosco tutto.
Oh yeah, I've heard that one.
Knows everything. Tuto.
that sounds a lot like Spanish for I remember everything.
All right.
Anyway.
So
Awkward silence on the Baseline show.
Yeah,
Yes,
we're not used to being live
it's
from
awesome.
Italy. It's a little different.
It's
Yeah,
very
very
different.
The vibe is different today. We are on the 24th of August, and we welcome everybody who's baselining and who is intending to baseline. Let me introduce everybody to Vaibhav Maheshwari once again. He's recently won the grant for building currently using ZK and baseline currently. And today we have a very important baseline show where Vaibhav is going to display his work. Thank you, Vaibhav, and we hope the code works. So why don't we get started with Vaibhav, and people who may have not seen your earlier show. Why don't you introduce yourself and talk a little bit about your grant request and how did the idea come about, and what did you do? How do you go about it? What were the resources which helped you within the baseline Slack and the GitHub channels? And then Code Don't Lie. Yoav, I need you to play that Code
for
Don't Lie
sure.
segment. All right, over to you, Vaibhav. Take it away.
Yeah, so I basically attended ETH Amsterdam, and that's how I came to know about Amsterdam based and baseline. Yeah, I was actually looking forward to learn zero knowledge. Like I wanted to learn about zero knowledge circuits, like how to actually code them. I knew it in theory. So yeah, this was like a very big step for me. So yeah, that's how I came to know about what baseline calendar is. That the idea is to preserve your privacy when you set calendar appointments. And the idea is that let's say that you go ahead and share your calendar with someone else and they pick up a specific time slot. So they should not be able to use that to know other details about you, such as which times are blocked or whether you're meeting with someone else or not, or basically largely which times are blocked. And this can be done in Web 2 standards as well. But what ZK does is that what ZK allows us to do it in a way that's compiled inside browser itself rather than going it to a backend. So so my work, I will quickly go ahead and present the screen. So I'm actually so the front end part is still left. So the
So
complete
this is
demo.
yeah,
Yeah,
that's okay.
go
That's
ahead.
okay. This is where the code don't like comes in. So we have to pause for 30 seconds.
Okay. Yeah. I'm keeping my fingers crossed right now. So the front end still left.
Wait, yeah, can we actually play it?
We're back.
Do we have it? Oh,
They were there.
Yeah,
Yes.
doesn't lie.
Doesn't lie. Go ahead, Vaibhav.
There you go.
Wait, is it playing something?
Yeah, it's done, bro. It's done. It's gone.
Oh,
Now you
alright,
can go ahead.
Wait a second. Let me share my screen. Yeah, my screen is visible, I think.
Yeah, you're good.
So there are two parties. The one party is the giver. So giver is basically the person who is giving an appointment, and there is a seeker, the person who is seeking an appointment. So or setter or giver. So setter registers or logs in, and they set a time that they are available, and then they share a link with the person who is seeking an appointment, and then the person who is seeking an appointment goes to that link and sets a few times that they are available, and then the circuit computes basically the availability from two lists, and then either the appointment is success or appointment is failed. Now the proof, so the store, so the idea is that the proof is generated when the setter actually goes ahead and no, the proof is generated when the seeker goes ahead and goes to the appointment, select few ones, and the proof is verified afterwards by the person who set it. So this is like something like a battleship as well, where a player A does it and player B does it. Then like the player B verifies the whether player B marked or the ship or not. So something like that is over here as well. Yeah, this is the basic circuit working. Yeah. So so there's this date index, then there's seeker available time 1, time 2, time 3, and year index. Then there's public signal. These are the private signals, and these are the public signals. And then there's the output signal, which is the time selected. Then so Merkle tree with nodes as root of Merkle tree. And this time slot. I will just quickly show the code as well for this. So so there is a signal input of root of the tree. Then there is time slot leaves, there is time slot indices, and then there's time 1, 2, 3, and whether it's available or not. And then the tree gets assigned, and if there's a time slot which is available, then it goes ahead and computes as available. I'm using like basic Merkle tree from circomlib, and this part works. So right now what I'm trying to figure out is the date part and how to kind of associate the date with it. And so the idea would be to store that. And so this part works, and this is tested with this index. And so this works so far. And some of the front end is the front end part is there. So yeah, that's
Okay,
about it.
I found this on the web for is the funding for is left. Check it out.
Yeah. Oh, sorry about that.
What's this
The
happen?
Siri opened up and it started saying something.
Siri.
Yeah, Siri.
Used to- How about baseline?
Oh, right.
Yeah. Anyways, so yeah, that's about it. That's from my side. From the backend, in terms of like different APIs that are being done, which are like basically time appointment circuits, authentication appointments, yeah, like basic stuff. And there would be a truffle connect to, there would be a solidity file which is generated when this is compiled, and which would be the smart contract for verification, and that would be launched, and that would be basically done. In the Battleship code, in order to maintain non-persistent data, Kafka was used. But over here, I'm using Postgres as a DB, which is, yeah, that's about it. If there are any questions, I would love to take them.
Yeah, we can definitely ask some questions. So what was, I know you had like an original ZK circuit, right? And then, through talking to the community, you came up with this new structure of this community, Andreas, I'm sure. So what was really wrong with the first circuit? What did it not handle properly? Can you give some shout outs to the people dealing with ZK today, trying to wrap their minds around it?
Yeah, so what I did with the initial circuit was I was taking the time slot and I was hashing it, and then I was comparing it with and then I was basically comparing it with the original time slot. So and those had to be passed as so either the hash was exposed or the time slot was exposed in order to so I would have to have the corresponding private signal and corresponding public signal. So if there was a hash of the time slot, that would be a public signal, and the time slot itself would be a private signal inside the circuit. And then I would say that these are matching, and then you can go ahead and proceed with the thing. But the problem with that was that what I am trying to do is that I want an array of time slots, not a single time slot. Like the availability is an array of time slots. And how do you put that in a circuit is with the help of Merkle tree. Like the data structure that you use to kind of put that inside a circuit the best data structure would be Merkle tree. And that's what Andrea suggested to me in that GitHub issue. And I picked that up.
Are you working from an Outlook calendar, a Google calendar? What productivity platform are you sourcing the data from?
So there's nothing as of now. So right now it's a Calendly clone. So basically you set your own availabilities, and then you request other person to get other availabilities, and then they set it up.
Okay. So it's not pulling a feed directly from like your calendar, for example.
No.
Okay.
Not right now, but
There's going to be an excellent opportunity to write plugins for different calendars.
Mm-hmm.
Or maybe you can use it in Calendly. It's integrate that. So it's like, there are infinite extension capabilities to do that. So.
And just curious, like what was the light bulb moment that caused you to say, hey, I want to have a private shareable calendar beyond like what Calendarly already has today?
Well, the first thing is like the idea is that you want to share something which is private and valuable, and that's what makes blockchains valuable. So time is something valuable. So the thing is that if we have that, we don't want to reveal too much about it, the same way that we don't want to reveal things about our wealth or time. So the idea was that to have something in that direction. It was also one of the blip bounties which was put out by Baseline. So yeah.
Yeah, we got to shout out some credit to, I'm not really sure exactly the original idea, but definitely John, Andreas, somebody, every single other meeting I'd hear do Calendly. It's Baseline Calendly.
If we go back to some previous Baseline show recordings, we will actually find $1 million ideas there. Those were discussions between Andreas and John, and I have a separate note running in my laptop, just doing John Walpert thoughts.
I was actually looking when I was thinking to choose which bounty to work on. this was the only boundary which was discussed for 9 minutes, the rest were for 2 and 3 minutes. And I was like, this is something, interesting to work on. So yeah.
That's interesting.
Yeah, I had Sonal bug Andreas in New York so that I can listen to all of his conversations for great ideas.
That's how you get mugged on the street.
You're
I think
muted,
it's a-
Andreas, if you're trying to say something.
That's a digital mugging. That's not on the
Who's-
street. A digital mugging.
Who's Andreas?
The
Oh, my
rapper
alter
formerly
ego,
known
never
as
mind, I forgot.
Andreas.
Just kidding.
Vaibhav, it's great to hear that you got use out of those discussions because we never really know who else is listening out there other than our internal community who joins all the calls. So it's really great to hear that you were able to use all of those discussions on each of those blip ideas and make good use out of it. So we know that that's a good model for going forward.
Absolutely.
So did you find that this example, let's say baseline implementation of a calendar example, was something that was exciting while doing the coding?
It was challenging for sure. Like actually coding it was more difficult than I thought initially. So yeah, so like debugging it took more time. Like even this circuit, although like the concepts were like hard to understand a little bit, and so yeah, definitely challenging and exciting at the same time.
Super awesome. And I like that metric that you used, Vaibhav, which is how many minutes that the discussion went on. That's a clear indicator of how deep we dive on those ideas. Awesome. Any other questions to Vaibhav? And are there any questions on the social media? Yoav, do you have a handle on that?
Yeah, I think they should, as other people should like team up with and make a business out of this, because you can, privacy preserving calendars, right? As a it's like Google Calendar, Outlook, plugin.
Yeah.
That might not be actually a bad idea if you have that. You can productize that.
Yeah, the first people to jump on this will be the users of Proton Mail. Right? They would not be. They would not
Proton
be.
Mail.
Yeah, they would not be Gmail users who've surrendered their privacy to Google by using Gmail. So I think that could be that's a fantastic idea, Andreas. I think this could be.
You just need to get Google to buy out your idea. That's all you need.
That's the dream.
Forget about everything else.
Yeah,
I have a question for you. Are there any like shortcuts or tips that you found along the way that you want to share to ZK, like people starting out in their ZK development?
Well, so what I did was I just looked at the circom library, and then what I would do is paste some snippets of code on GitHub and search what other people are building using that circom library, and that used to be a reference for me. Like then I would understand that code and then use that reference for me to understand what to build on. It's like a hack kind of a thing. But yeah, I think the thing is that it's not very well documented so far. Like especially the circom library in itself is not well documented. So it was like more challenging to kind of understand what that code is actually doing, what is the input, what's the output, and stuff like that.
Cool, yeah.
How long did it take you to pull this together from start to finish?
Like it's not finished yet. The front end still left. So I think
obviously, but yeah, like to date, how long have you been working on it?
Well, I've no, so it's not like I'm continuously working on it. I'm also doing my job on the side. So this is more of a side hustle for me. So I would say on and off for I don't know. I think if you cumulatively, I would put it at 1 month, 1.5 months, 1 month.
Good stuff.
So there's a question from Lingaraj. So he says, great presentation, V. Can we use circumlibrary for creating complex circuits that we need in financial instruments?
I think, okay, I would answer that. Yes, you can. I mean, I'm not an expert, but you can. So circuits enable you to verify a source of truth without revealing the information, and that's what the purpose of it. Now the information and the truth can be anything, including financial instruments.
Awesome.
So it's a little yeah, you can, but depending on what you need to do, it will you need to do a little bit of like creative thinking, because for example, if you have digital assets with residuals and you need to ensure that all payments have been made, right? Things like that. There's some interesting things that can be done that require more complex things like recursion. So, but luckily, that support it.
Because it's not something I was exploring, but yeah.
Oh.
On the question of financial instruments, I think Boris had a grant he was working on ZK circuits for bond markets. Yeah, so Lingaraj, you can actually refer to the older grants as well. Maybe we can post a link. And yeah, Sonal asked a very good question to you, Vaibhav, which is what are your future ZK projects that you're interested in working on?
So I had this idea, which is right now what Tornado does is that it allows you to kind of mask your payments. But the thing is that whenever I'm receiving some payments, I'm not able to mask them. So the idea is that instead of sharing an address, my own address, so if I share my own address, everyone can see what do I hold exactly. So whenever I'm requesting some payment, I would like to build something there that I can just share a pseudo address or pseudo link or something like that, where that person can just have to enter the amount and just pay, and they don't know what my address is. So yeah, that's the one use case that I found very interesting, which kind of doesn't, I don't know if it exists, but it's kind of, I'm curious about it basically.
Awesome.
Private payments exist. You can, I mean, not as roll-ups, but actual private payments exists. You can do that with Aztec, or you can do it on you can also do it on Starknet. So it requires a little bit of you still need an identifier of an individual. You don't need to know their account. You just need to have an identifier of the individual.
I think to a large extent, ENS use cases, ENS had this as one of the biggest use cases, right? You mask your address. I mean, there was a time when you used to think addresses are anonymous, but then people started figuring things out using the addresses. And then I think that was one of the reasons why ENS was able to sell a lot of domains earlier.
Yeah, I mean, ENS has no privacy. So I mean, what you can do is you can utilize DIDs, and then you use service endpoints that allow you to then send a payment to that. But it's still you will if you need perfect privacy, you will need some intermediary in some complete black box in between.
Yeah.
And while we are at the subject of Tornado Cash, Andreas, why don't you let me bring you in, and why don't you finish that conversation we were having in the last episode? You were just getting started on explaining us what went wrong and how did the whole thing happen.
Why it happened? Well, obviously, the CIA is not that happy that North Korea can launder money, you know, supposedly a few $100 million. So again, there still needs to be what obviously they didn't say is that, you know, laundering a few $100 million in crypto is great, but it has to be converted into fiat currency sometime, somewhere. Because last time I checked, you know, it's like, you know, there were no, you know, North Korea was not the you know, ETH was not the primary currency in North Korea. So the target is wrong, but the implication of putting a protocol and associated code, aka this, you know, the smart contract addresses of Tornado Cash, on the list is concerning, because it opens the door, if that were to stand as a precedent for basically any open source project could be sanctioned, and therefore every single user of that protocol, not only going forward but also retroactively, would be a criminal. So if the US Treasury were to decide that Ethereum, every single Ethereum user ever, would be a felon, and they would have to turn over all of their crypto holdings and all of their fiat holdings derived from that crypto holdings to the US Treasury. Hey Vitalik, I think you wouldn't like that. Hey Joe, you wouldn't like that either. So or Sung or whoever is or Dorsey with his Bitcoin holdings, if they were to decide, hey, Bitcoin is now on the sanction list. Yeah, so that's there are broader implications going forward. I think Tornado Cash is just a simple canary in the coal mine to see if they can get away with it, which they will not. There is, at least in the US, there's Supreme Court precedent about First Amendment rights and freedom of speech. You have to show causality, immediate causality, between a speech and an illegal act. So
cool. That's interesting. And I was actually reading on Twitter that a lot of people are transferring small amounts, very small amounts of ETH to different people's wallets, just to
celebrities. Yes, so they're basically all criminals right now.
Yeah.
Just to implicate them.
Yeah. But I think what I really liked was, a few days back I read that there was some court in the US, they issued a notice to a hacker and they dropped it as an NFT in their wallet. Was that in the US?
I don't know, but that's something that DMCA notices could be effectively distributed this way, as an NFT drop associated with an IPFS page that is a notice.
Interesting. Okay, so I think we've covered Vaibhav's walkthrough of the Baseline Currently app, and we've also got to know a lot about Tornado Cash. It's sort of the news in the crypto world right now. Let me now open the floor to everybody who's on this call and also watching us live via YouTube, LinkedIn, Twitter, and any other channels. So yeah, if there are any questions, comments, if there's anybody who's working on something interesting and like to share, please do.
So I would really like to see people starting to also, use different types of prover systems, right? So you're using like, CIRCOM or NARC or something like that. Those are all ZK SNARKs, right? Which require trusted setup. StarkX has just or Starkware has just upgraded StarkX to be able to support recursive proofs. Therefore, it would be really interesting to see the experiences and recursive proofs supported in their language, Cairo. So it would be great to see if people were to start using that, because Starks obviously don't require a trusted setup. They have advantages and disadvantages. So it would be great if people were to start utilizing that and share their experiences with that. So that's my hope, because it's Starks are very interesting alternative to Snarks. Again, they have advantages and disadvantages. Advantages are that your the amount of data that you need to generate the proof is lower. So prover time tends to be lower, but but verification grows sublinearly. So the proof grows versus Snarks where proof size is constant, which means verifier time is constant. So it would be great to see if some usage of that, or just offering multiple different prover systems in an application for people to pick and choose based on their use case need. So I think that's going to be important also for, just generally speaking, for baseline implementations. You will have to offer different types of ZK prover systems, whether those are it's like Merkle proofs, Snarks, Starks, bulletproof.
Yeah, and what's which one is post quantum secure? Isn't Starks or post quantum secure?
Starks are
bulletproofs or not?
Yeah, Starks are post quantum secure because their only security assumption is that hash functions are one way only. So basically, the logarithmic Diffie-Hellman problem remains hard in cryptography terms. So that because of that, they have safety against quantum attacks, because hashing is not amenable to quantum attacks.
That could be a blip, actually. That could be a blip. Isn't that a blip idea, which we should invite people to apply for grants working on this, right? Having baseline applications with different prover systems.
Yeah, should we take like existing examples, implementations,
Yeah.
and tell them to be done under different Snarks bulletproofs rather Snarks, or what do you guys think?
Yeah, you can, what's the difference in experience if you play Battleship
Ooh.
using Snarks versus Starks? Right? Can you, so here's the interesting thing. Can you play multiple games against different partners? It's like, do you always have to do a trusted setup? If a new partner comes along, does he trust that trusted setup that you did? It's like, if not, then you need to start a new one, which means you need to maintain multiple prover system data sets at the same time, versus with Starks you don't. So interesting choice. Right? The same thing is like, hey, can we do Battleship with Merkle proofs? Right? If you think about it, right? Battleship is like booking an appointment.
An appointment with death.
No, a calendar appointment. It's like Keith, you're like you're like really morbid right now. But that's
You said
okay.
Battleship, right?
I said Battleship, but I said an appointment. It's like,
Yeah.
I wanted to reference to the great work that V did.
Oh yeah. That was great. I mean, yeah. But
So
also
you can-
Battleship is like,
It's an
trying to kill your
appointment with
enemy.
death. That's true. It's if you want to frame it this way, yes. No, there's a certain truth to that. Lambda would agree.
Okay,
Ask Keith
everybody
about
heard it.
drones.
You heard it right here for the first time in my life. Lambda told me that I was right about something.
Not
Yeah,
true.
it's
Hey,
on
you've
recording
been
and also
right
on live video.
before.
Oh, the
You
stream
know.
cut out. I think we lost the last.
My life is complete. No, my life is complete, guys.
Excellent. Yeah, no, so I think that's an interesting, if you want to add, multiple prover systems to Battleship and see which one's more performant for that. So it would be, that's a fun little
Performance is measured how exactly?
well, how long does it take for a move to be completed? Right. So how long does it take? How long does it take for, in Battleship to verify whether it was a hit or a miss? Right. Using Merkle proofs, using Snarks, using Starks.
Okay, yeah.
Yeah,
That's
and
an-
then maybe go ahead.
No, that's very interesting to kind of learn about, because but most of the processing is because of the hashing, like which hashing you use, instead of like what the data structure is. Like it's the time difference is more because if you're using different techniques, whether you're using solid, like there are multiple libraries in Circom itself, which provide with different hashing methods. So that determines, I think that determines the time more. That should determine, I believe, the time. I believe.
Yeah, I mean, it's whether you're using like a Blake 2 hash, or Blake 2B, Blake 2C, or whether you're using SHA-3.
Yeah, and I think that's a lot of the focus of some of the Z Prize stuff, is really accelerating all kinds of different operations. One of them is actually accelerating the Poseidon hash function. Vaibhav, if you want to, I don't know, do that, and I think the prize is like a couple $100,000. So
Yeah, that's real work, right? I mean,
Yeah.
that's like slightly
triple real.
Yeah, that's like you really need to like, think about, it's like how to optimize implementations without creating leakage. Right? That's a big thing, right? I mean, I can do a really fast implementation, but it's not secure because I'm leaking information. Right? An algorithm might be secure, but provably secure. Your implementation might not be. In fact, most are not, or a lot of them are not. They have edge cases. Where you can start bleeding information. So it's an interesting it's an interesting challenge.
Bleeding. How morbid of you, Lambda.
Lambda has no blood.
Leaking. Leaking.
It's the same for an AI, right?
It's semantically different, practically can be the same. Or seeping. While we're at semantic differences.
Access to a whole thesaurus.
That's
all right.
Somebody
in zero knowledge. Yeah, another blip. Like most mundane things, do them in zero knowledge. It's like, can you come up with a library of zero knowledge proofs of the most mundane things? Like it's like the trash was taken out in zero knowledge.
Prove it.
Yeah, that could be a drinking game,
It's actually you could make it. I mean, imagine it's like multi-party coordination under zero knowledge. Who takes the trash out? Provably so,
yeah.
But in zero knowledge. So it's like, how do you do that? Anyway.
You tell me.
Interesting, freewheeling discussion. But you know what? I was wondering, somebody like Vaibhav would come in and watch these baseline shows maybe a year from now and say, yeah, I must read about Cornhole and Lambda. A lot of minutes were discussed. We've discussed these topics, but this is very interesting. And yeah, Andres, I think this freewheeling discussion should happen about what all could be done potentially in the world around us in vain zero knowledge.
Yep, it's interesting.
Yeah.
Yeah.
And by the way, since I have two very important and actually everybody very important on baseline show today who talks about ZK. So we have an upcoming event in East Vietnam, and they are open to have us do their workshops. And I had pitched for two workshops. One was the business side of baseline, and the other side was ZK. So yeah, guys, please, Andreas, Keith, whoever would like to take it up, please let me know. But it will be in Vietnam time.
I haven't been to Vietnam yet.
Oh, you want to come down? I don't think they have the budget for it.
If Lambda's there, I'm going there.
I'm already there. I'm
already there.
I'm already there.
Like in your state of mind, or really?
I'm always there.
Are you always everywhere?
I'm always everywhere.
That means that you're always in my heart.
That is digitally difficult, but I appreciate the sentiment.
That calls for applause.
If you had a pacemaker that was connected to your phone, completely different story. But you don't.
Well, you know me, you know me so well.
So, but actually, so here's an interesting. This is more not really a thought experiment, but imagine you have human computer interfaces,
Yeah.
right? So how do you ensure, privacy of thought?
Baseline. No, sorry.
No, or sharing insights under zero knowledge,
Yeah.
right? Without revealing, coordinating. It's like you can already, right? For people who with MS and so forth who can't speak anymore, you can already turn brain waves into written language, and you can obviously then use a converter to do that in audio, right? So
Yeah.
but once you're connecting people, right, so that they can, it's like that you can share these things amongst others in a not only in a visual but in an audio way, then if you're how can you ensure that these type of things remain private?
Yeah. How do I maintain my individuality from the hive mind that I'm connecting to in the cyborg future?
In a way that is not an way out thing to think about, because it's coming, right? So what do you do with when you have nanites that are used for diagnostics, and they're constantly, right? So what do you do with data from your hearing aids, from your pacemaker, from your insulin pump, right? Not only how do you protect it, but how do you ensure privacy of that information, and ensure that you can coordinate around it in potentially in zero knowledge.
Yeah, good point. Maybe, and then like transmit that data under zero knowledge in real time to my doctor, to my AI doctor.
Yeah, well, also, yeah, it's again where you're not necessarily guaranteed, because you have no control over that data. It becomes but it's still important that it's being analyzed. You need to ensure that privacy is maintained.
But say if I do want control over my cyborg implant data.
Well, you should, right?
Yeah, I do.
Ideally you do, right? So it's but if you you need to, it's like if your cyborg lag goes haywire and starts randomly kicking your cat or a dog, or girlfriend, child, father, mother, uncle and aunts. So then what do you do, right?
Reboot.
Did you try turning it off and on again?
That is one thing, right? And then it's like, what do you do with firmware updates?
Yeah.
Right. So there's the question about privacy's coordination under zero knowledge is as we're getting more connected, not only from our devices but from our bodies themselves, therefore many more data sources, becomes a really relevant, not only philosophical but just very practical question. right? Because if I can identify an endpoint, I can hack that endpoint.
Yeah. So back to the original, we're meeting in Vietnam, right?
Yeah, please do. Or conduct a virtual session. Both are acceptable. So do let me know.
I'll take your
Uh,
silence as a yes.
He said that he's
Alright.
already there.
Yeah.
Okay.
The food's great, by the way.
Oh yeah, that's awesome. That's amazing. Okay, I think we are on the top of the hour almost, and we can comfortably call it a show.
Wait,
Um,
share the
hey.
news first.
Oh
about-
yeah, let me share the news. Yes. How
Ooh.
could I miss it? So,
Nice.
and for everybody here and also the viewers, I have recently got approval on my grant request to conduct the baseline show. So you'll be seeing a lot of me and some formats, some ideas. I think the larger idea behind me requesting that grant was also to have more engagement with the speakers before and after the shows. So not just inviting them, having a chat and letting them go, or rather making them ambassadors of baseline. So that was the whole idea of spending time with them, both before and after the show, and so they could go back to their respective organizations and let us know if there can be doors which can be opened. They get us to the right tables. So that would be my endeavor going forward. There are 2 or 3 segments which I've planned for the show, and yeah, I will keep experimenting and growing, as we go along. But yeah, this is very good. I will also be merging the India show with the international show now, so there may be a time change, but of course, if the community agrees, if it does not agree, then we will retain the same time. It's slightly later in the day for eastern side of the world. For India, it's still okay, but yeah, if you go further east, let's say Kuala Lumpur, where I am, or Singapore time, it's like midnight. People are already taking their dreams. So um, so yeah, we'll figure that out. But I'm very grateful to everybody who voted, and I look forward to a fulfilling experience doing this. This is just for till the end of this year, and let's see if you guys think I'm doing a good job, please retain me. All right, so that's it about my grant and the upcoming shows. We have some speakers lined up, and please do keep sending me and everybody else the recommendations for future speakers. Um, I think we're going to be having a lot more intense conversations going forward, especially when we have things to showcase to them and get their feedback live on the show.
Excellent.
Woo! Yeah.
Thank you,
awesome.
everyone.
Thank
Yeah,
you.
check out our
Thank you all.
podcast, Book of Lambda, every day right after the baseline show.
Yeah,
Book
that's
of
the
Lambda.
that's the after hours of baseline official hours, official office
Yeah.
hours.
And that's
All
my
right.
time to leave. Have good day, everybody.
Yeah, that's what the podcast is. It's just kicking
Yeah.
Zonal out. That's
Yeah, it's time to leave.
When
We
the
gotta get
fun
season of
started.
the movie.
Have fun. Cheers. Bye.
Enjoy.
Thank you, everybody.
Yeah.
Okay, bye.
All right, Keith, get it
Lambda.
started.
All right, guys, let's open our books. Go to page 1, Book of Lambda.
Page 1, Book of Lambda. Okay.
And thus Lambda spoke into existence.
Yeah. Okay.
All that we know and all that is. Did you cancel the stream?
No. Keep
No?
going.
I don't believe you anymore. I gotta check. I gotta check the
well,
tube.
well, we're live, so keep it running, Keith.
I gotta check the
Keep
tube.
going. Is that the post
Keith,
the
what's on
post show
page 3?
live stream?
That was just a little taste. They can't.
Oh.
They
Just a
gotta
little
tune
taste.
into the Book of Lambda podcast, right? We don't want all of our
Oh, yeah, it's
fans
just a
coming
teaser,
here,
right?
You know what I'm saying?
It's
I
just
see.
a
All
teaser.
right. Well, stay tuned, everybody. For the Book
Yeah.
of Lambda, episode 1, season 1, dropping
6
in the future.
seasons and a movie.
All right. Thank you.
Yeah.
Thank you, everybody. Enjoy.
Take care. Cheers. Bye.